Okay, one last thing I wanted to mention about case pattern matching is that we can use it with the Scala built-in types as well as our own homemade case classes. So for instance, we can do the same is list ascending, but with Scala lists as opposed to this homebrewed my list. So in Scala, instead of the empty list to signal the empty list, we have what's called nil. And right, instead of the cons construction with, say, head, tail, we end up with something that looks like this: head, colon, colon, tail. So this is the same construction with the head and then the rest of a list. But instead of the prefix notation, which is what we were using with cons, it uses an infix notation, right? Prefix means that the binary operation comes first, right? So we say in cons and then we say the left and the right. Infix says it goes in between the left and the right terms. So there's really not too much of a difference going on here, but let's just write up is list ascending for Scala list submits, just to sort of see what that looks like. So we have is list ascending on a list of ints, and it's going to return a boolean. And what are we going to do? We're going to match on this list. And in the case that it's nil, right, the empty list, well, that's trivially ascending. The case when we have something like underscore and then nil, right, so the idea is I don't care what the head is, as long as there's only one element of this list, then I'm going to return true. Case when we have head, colon, colon, head 2, colon, colon, underscore, right, so the idea is here I've already sort of split out the first two elements of this list just using these colon colons, and the tail I can ignore with the underscore. And then of course I can preference this that, right, if head 2 is less than or equal to head, then return false. So again, I've qualified this. I'm just basically copying this last version that we had, but using the built-in Scala notation instead. And then case when I have, when it turns out that head 2 is bigger than head, right, so we're in ascending for at least the first two elements, then I have something that looks like something with the tail, and I'm going to recurse on that tail. Right, and then of course we want to make sure to catch any other cases that might come through. On a list, these are basically the only cases, but it's always useful to add this in here. Exception. Just no, we shouldn't get to this location. And that compiles correctly, so let's just run this on a demo list. It's going to be a list of, say, 1, 2, 3, 4. That returns true, and let's just make a non-ascending list. And we get false. So you can see it all works out. You can use lists, you can use go through maps and a variety of other data structures that are built into Scala. All of this stuff about case pattern matching can be found in the operations inductively defined structures notebook, which has all these examples and more in it. So I highly recommend going through all of this. It might be a little more than even you need, but it's useful. You'll be coming back to this frequently as we go through this semester. All right, that's all I wanted to add to this lecture. Next, I'll talk about parsers.